Example 6, the convergence of the series, the sum from n equals 1 to infinity of open 2n plus 3 over 3n plus 2 close to the power n. Solution a sub n equals open 2n plus 3 over 3n plus 2 close to the power n. The nth root of the absolute value of a sub n equals 2n plus 3 over 3n plus 2, which equals 2 plus 3 over n over 3 plus 2 over n approaches 2 over 3, which is less than 1. Thus the given series is absolutely convergent and therefore convergent by the root test. Rearrangements. The question of whether a given convergent series is absolutely convergent or conditionally convergent has a bearing on the question of whether infinite sums behave like finite sums. If we rearrange the order of the sum of the terms in a finite sum, then of course the value of the sum remains unchanged. But this is not always the case for an infinite series. By a rearrangement of an infinite series, the sum of a sub n, we mean a series obtained by simply changing the order of the terms. For instance, a rearrangement of the sum of a sub n could start as follows. A sub 1 plus a sub 2 plus a sub 5 plus a sub 3 plus a sub 4 plus a sub 15 plus a sub 6 plus a sub 7 plus a sub 20 plus and so forth. It turns out that if the sum of a sub n is an absolutely convergent series with sum s, then any rearrangement of the sum of a sub n has the same sum s. However, any conditionally convergent series can be rearranged to give a different sum. To illustrate this fact, let's consider the alternating harmonic series. Equation 6, number 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6 plus 1/7 minus 1/8 plus ellipsis equals natural log of 2. See exercise 11.5.36. If we multiply this series by 1/2, we get 1/2 minus 1/4 plus 1/6 minus 1/8 plus and so forth equals 1/2 times the natural log of 2. Sidebar, adding the zeros does not affect the sum of the series. Each term in the sequence of partial sums is repeated, but the limit is the same. Back to the text. Inserting zeros between the terms of the series, we have equation 7. 0 plus 1/2 plus 0 minus 1/4 plus 0 plus 1/6 plus 0 minus 1/8 plus ellipsis equals 1/2 the natural log of 2. Now we add the series in equation 6 and 7 using theorem 11.2.8. Equation 8, 1 plus 1/3 minus 1/2 plus 1/5 plus 1/7 minus 1/4 plus ellipsis and so forth equals 3/2 times the natural log of 2. Notice that the series in equation 8 contains the same terms as in equation 6, but rearranged so that one negative term occurs after each pair of positive terms. The sums of these series, however, are different. In fact, Rayman proved that if the sum of a sub n is a conditionally convergent series and R is any real number whatsoever, then there is a rearrangement of the sum of a sub n that has a sum equal to R. A proof of this fact is outlined in exercise 52.